welcome back to my channel. If you watched my last video, you know that I've been playing around with casting aluminum blocks from scrap in order to use while messing around in the shop. One of the other things I decided to try reproducing from aluminum is my vane supercharger. Here's where I am currently. I have to do a little bit more to finish it up, but it's mostly there. All I have to do is the end caps and I'll be ready to put it together. The profile of the rotor has been modified a little bit. This gives me a little bit more volume in the chamber, lowering the pressure spikes on the output side, smoothing the flow slightly, at least theoretically. Off camera, I had tested the improved vane pump at some higher RPM. I would have done it on camera, but it ended very quickly at around 5,000 RPM. It started to load up hard, so I shut it down. After that, it was semi-seized until it cooled down. It seemed that the max RPM for the material combination I'm using is around 4,500 RPM, at least safely and continuously, and that's with oil going into the intake. The problem with that is I intended to use the vane supercharger on an engine that is designed to be, in the range of maybe 7 to 10,000 RPM, if not higher. The reasons I wanted to use a vane pump over the regenerative pump is because I managed 3 psi over the 2 psi out of the regenerative pump with the vane pump, and the more pressure the better. I had some issues with the regenerative pumps, the 2-stage version with the belt drive system. I realized that it was slipping and wasn't driving under load, so I don't actually know what the full deadheaded pressure test on that is, but I will do that in the future. So for now I'm going to move forward with this concept with the vane pump. The advantages that the aluminum housing should give me are as followed. 1. Far less heat expansion of the housing allows me to run much tighter tolerances, increasing pressure, efficiency, and airflow. 2. The plastic housing, even having carbon fiber in it, still pales in comparison to the cooling and heat transfer characteristics of the aluminum. 3. As far as I can tell, the friction coefficient of PETG to aluminum is a lot less than PET to PETG, even if with the carbon fiber, as well as being able to get a much smoother finish on the housing, which will help with sealing and rotating efficiency, as well as less heat reduction and, well, a better seal all across the board. Now we're going to look at the concept drawing for my engine. It's not a new design, but it's also not a very common one. Like most engine designs, it's been around for over 100 years. I have always loved two-stroke engines, and this design aims to solve, or at least attempt to solve, some of the normal issues in two-stroke engines. The first part of this design we're going to talk about is the crank oiling system. The crank I'm using was stolen from a 50cc two-stroke chainsaw, and as such comes with ball and roller bearings throughout. Normally the fresh air charge mixes with the gas and oil in the carb when using premix, then heads into the crankcase. In this design, the air-fuel mix never goes into the crankcase, allowing me to drastically lower the oil mixed in with the gas, and completely eliminate it if I end up going with the non-contact air pump doing the scavenging work. So to replace the oil normally mixed into the fuel, I plan on running a low-pressure dry sump system, about 3 to 5 psi, with a gravity drain with a tank right below the crankcase. I'm hoping this will work out pretty well. As well as allowing me to remove the oil mixed into the fuel, I can add a piston cooling jet which should lower the combustion chamber temperature. This allows for higher compression ratios, either by forcing more air into the cylinder with boost pressure or having a smaller combustion chamber, both increasing volumetric efficiency. However, with the higher boost pressure, scavenging efficiency will be improved. The next thing I want to talk about is the porting. So the intake port being above the exhaust port. Your standard two-stroke engine usually has the ports relatively on the same plane. Of course, as you go up in higher performance, things get different, but because I'm running boost, I want to be able to close off the exhaust port while having the intake port open and be able to stuff as much air into the cylinder before the piston goes up and closes the port off. On the intake side, I will be placing a reed valve between the air pump and the cylinder to stop any exhaust gases from heading back into the supercharger and maybe the carburetor. I'm likely going to have to play around with the plenum volume between the reed valve and the cylinder to kind of optimize how much backflow there is, because there is going to be a little bit as the exhaust stroke happens and the pressure goes up, but the pressure will build up drastically and it shouldn't get to the reed valve. I might have to keep the reed valve farther away or as far away as possible, as well as maybe putting cooling fins on the reed valve box to try and keep everything from getting too hot, because it's likely going to get pretty hot down there. In other cases, the porting or valving on this type of engine would have been done with either rotary valves or normal poppet valves on the top of the engine controlled by a cam, which is probably the long-term solution for any of the issues in this, and that might be where I end up with this. It's just a lot more complicated, and this will be a lot easier to get something working right off the hop. I plan on starting off with rather small ports ported externally, as I'll be able to get access to them that way, and kind of die grind my way up as I go once it's running. That's going to mean a lot of build and disassemble of the engine, but I'm going to try and design it so that shouldn't be too much of an issue and get it apart real quick and put it back together after porting it. Currently, I'm not really far into this project. I'm still kind of in the design phase. I have the concept, and as you can see, I've been working on some of the drawings in Fusion to get up models, and I have some parts, or I should say ingots cast, so that I can have a chunk of material to start from. Well, that pretty much covers everything I had to update you guys on this project. As the weather warms up, the rate that I work on this stuff should increase a little bit and spend a little bit more time out in the garage. I have a fair amount of work left to do on the drawing as it is before I get into the shop anyways, but next time I'm back with more about this project. Hopefully I'll be machining some parts up after getting everything sorted out in Fusion. Anyways, I'm going to leave you guys here with this, and if you want to click the like button, click subscribe, and I'll be back with more. Thanks for watching.